Welcome to Hobby Electronics. This is 72nd episode in understanding the microcontroller. Objective: to make digital clock using IC CD4026. Yes, the methods of making digital clock. There is no single official number available. There are 4 primary methods to build a digital clock based on the core hardware, software, and mechanical variation. The main difference between these approaches is how the time is calculated and how that data is processed to human readable numbers. 1. Microcontroller method. This is the most common do it by yourself and commercial method. A programmable chip controls the timing and output the data to a display. Working. The microcontroller uses internal oscillator or an external crystal to count seconds. Because microcontrollers can drift slightly over time, developers often pair them with real-time clock module like DS1307, which keeps the highly accurate time during the tiny coin cell battery. Common platform: Arduino Uno or Nano, ESP32, with or without Wi-Fi, or Raspberry Pico used. Displays use 7-segment LEDs, LCD screens, or OLED displays. 2. Discrete logic IC method, the old school way. This method requires no programming or coding whatsoever. It relies entirely on hardwired computer chip to do basic math. How it works? A quartz crystal oscillator generates high frequency pulse, usually 32,768 Hz. A frequency divider chip slows it down to exactly 1 pulse per second. Then the decade counter chips like 4518 or 74LS90 count the pulses from 0 to 59 per second, minutes, resetting and sending pulse to the next chain when they hit the limit. The components: CMOS or TTL integrated circuits, logic gates, and BCD to 7-segment decoders used. The example circuit diagram of CD4026 based digital clock. This circuit uses 4060 as a pulse generator. 2 Hz pulse is slowed down by 4026 IC, and 6 ICs are driving the clock: seconds, minutes, and hour. This can only display clock, and one more additional IC of 7411 is needed to control the limit of the time because of the fact that 4026 is a decade counter. The ICs used: 7411 is a 3-input NAND gate IC, CD4026, CD4060. 3. Dedicated clock chip method, the 1980s appliance way. Before microcontroller became cheap, semiconductor companies manufactured single chip designed only solely to run digital clock. How it works? All the dividers, counters, and display drivers mentioned in the logic method are minimized into a single specialized integrated circuit. Components: legacy IC like MM5314 or LM8560 are the example. You have to simply attach the power source, a crystal frequency source, a few buttons to set the time, and a LED panel directly to the chip. This is the image of the LM860 IC. All the clock function built into one chip. It costs now 1,250 in Indian rupees. The MM5341 is obsolete and it's not available. The vintage MM5341 chip is obsolete military industrial grade microcircuit. National Semiconductor has produced this chip. There is no single modern drop-in replacement for this chip that will directly fit into the volt slot. Method 4. Mains AC frequency tracking method. Instead of using quartz crystal to find a 1 second pulse, this method plugs into your household wall outlet for its time reference. How it works? The power grid maintains highly stable alternating current frequency. It is 60 Hz in North America and 50 Hz in Europe and in India. A step-down transformer safely lowers the voltage and basic circuit isolates the AC wave peaks. A counter circuit then counts exactly 60 waves to make one lapse the second. Non-hardware and creative variation. Beyond physical circuitry, digital clock can also be constructed through alternative mediums. Software-based clock, built entirely in code utilizing program language like Python, JavaScript or C++. They pull time from the operating system internal clock or an online network time protocol server and display it visually on the computer monitor or the phone screen. Electromechanical 7-segment clocks, a hybrid approach where microcontroller processes the digital time but uses physical servo motor to or electromagnet to mechanically flip the segment to reveal the numbers. Availability of kit for clock based on 4026. A fully pre-assembled retail-ready digital clock based on CD4026 chip is not readily available to buy off the shelf. Modern commercial clock rely on the dirt cheap, highly accurate microcontroller microchips, discrete logic-based clocks. The CD4026 have been entirely phased out of the mainstream manufacturing. The reason for non-availability of ready-made kits. The general do-it-by-yourself digital clock kits on retail platform like Amazon will find mostly kits controlled by small 8-pin microcontroller rather than CMOS logic gates. Microcontroller kits are vastly more popular because they require far fewer individual components. They track time more reliably and easily, include bonus features like automated brightness adjustment, temperature and date display. The Arduino Uno and 4026 IC based clock. The Uno controlled 4026 based clock and calendar circuit diagram is presented in this page. Components needed: 330 ohms, 1/4 watt, 45 numbers, 10K, 1/4 watt, 1 number, DS3231 RTC module, 1 number, Arduino Uno, 1 number, 2-pin tactile switch, 5 numbers, jumper wires and breadboard. CD4026 IC description. The CD4026 IC is a 16-pin CMOS digital integrated circuit that combines 5-stage Johnson decade counter with 7-segment decoder. It counts incoming clock pulse from 0 to 9 and directly drives a common cathode 7-segment LED display without needing a microcontroller. The main feature, dual function, acts as both decade counter and a 7-segment driver. Voltage range 3 volt to 18 volt DC. Display compatibility, designed specifically for common cathode display. Cascading output includes a carry-out pin to link the multiple IC together for multiple digit counting. Low power, uses very little power, typical of CMOS 4000 series. The pin configuration and function description is given in this page. One can also refer to the data sheet of the IC manufacturer for details. Wiring of CD4026. Using individual CD4026 IC means you need a dedicated chip for every single 7-segment display digit. A full 6-digit clock, hours, minutes, second, you need 6 CD4026 IC and 6 7-segment display common cathode. To make the code work correctly with the individual chip, you must cascade them in pair using the clock inhibit and carry out pin 5 pins. Chip-to-chip cascading architecture. The code groups the display into 3 independent pulsing channels: seconds, day, minutes, month, hours, year. The 6 chips are wired as 3 independent 2-digit counter block. Within each 2-digit block, wire them like this so that the 10th digit automatically counts when the 1st digit roll over from 9 to 0. Full 6-digit hardware wiring guide. To prevent ghost numbers or frozen display, every individual chip must have its own control pin tied to the correct voltage level. Power and display type. Display requirement. You must use common cathode 7-segment display. The CD4026 output a high signal to turn the segment on. Resistors. Connect 220 or 330 ohm resistor between each display segment and the IC. Connect the common cathode to the ground to protect the LED. The standard pin connection for all 6 is given in the table. Pin 3 connected to 5 volt. Pin 2 connected to ground. Pin 15 connected to Arduino pin 7. All the pin 7s of 6 ICs are connected together and connected to Arduino IC pin 7. Pin 16 VDD 5 volt power supply. Pin 8 VSS ground power supply. Pin 6, 7, 9, 10, 12 and 13 display segments from A to G respectively. Arduino control pin connection. Second day pair, rightmost 2-digit. Connect Arduino pin 8 to pin 1 of the seconds 1 chip. Minutes month pair, middle 2-digit. Connect Arduino pin 9 to pin 1 of the minutes 1 chip. Hour year pair, leftmost 2-digit. Connect Arduino pin 10 to pin 1 of the hours 1 chip. 3. Critical hardware troubleshooting tips. Floating pins. Do not leave pin 2 clock inhibit or pin 15 reset disconnected on any chip. Floating pin pick up static electricity from the air, causing digits to skip numbers randomly or freeze. Decoupling capacitor. Place 0.1 microfarad ceramic capacitor physically close to VDD pin 16 and VSS pin 8 of each CD4026 chip. High-speed counting pulses create power spike that can glitch neighboring chip. The blanking pin, pin number 14. Leave pin 14 unused, common blanking disconnected. The following section shows the code used for running the digital clock. Initialization of the variables and inclusion of libraries needed for this coding is given in this page. The microcontroller once only executing function setup code is given in this page. Here most of the initialization happens and pin assignment happens. The code of the send pulse function is given here. The subroutine for pulse BCD pair is given in this section. The trigger global reset subfunction and read RTC subfunction is given in this page. The code in the loop is given in this page. This page contains the continuation of the code in the loop. This page also contains the continuation of the code in the loop. Please contact the author, YouTube owner for a copy of the software Arduino Uno INO file. This page also contains the continuation of the code in the loop. Working of this code is described in this section. Working overview. This code drives a unique clock and calendar display using CD4026 IC. The CD4026 is a 5-stage Johnson decade counter that directly drives 7-segment display. Every time it receives a high pulse on the clock pin, it advances the display number by 1. Because the CD4026 has no memory of absolute time, your Arduino acts as the brain, calculating exactly how many pulses to blast down the wire to force the physical display to match the RTC internal time. Hardware architecture and pin configuration. The code separates the system into distinct operational group. Display control pins 7, 8, 9, 10. The pin 7 sends master resetter pulse to instantly wipe all the display back to 0. Pins 8, 9, 10 send rapid high-low clock train to step the second, day, minutes, month and hour year display module respectively. Buzzer pin 11 controls the simple active alarm transducer. Input interference 2, 3, 4, 5, 6 setup using input pull-up. This pulls the pin to high internally. Pressing a button connects them to the ground low. You need not externally wire a resistor. 2. Core operational logic. The pulse generation engine. Syn pulse and pulse BCD pair is the key component of this coding. Instead of standard library data buses, the CD4026 demand a raw sequential count. The syn pulse function runs a loop that toggles pin high and low with a microsecond delay. If Arduino wants to display a pair to show the number 34, pulses BCD pair extracts the integer value of the commands send pulse pin 34. The 4026 receives exactly 34 microsecond pulses in a fraction of a millisecond, advancing the display from 0 to 34 instantly before human eye can track the stepping. Multiplexed time date presentation. In run mode, when the current mode variable has a 0, the loop constantly checks if a new second has ticked over via if second not function. When it changes, it sends global master reset down the pin 7, clearing all 7 segment display to 0. Seconds 00 to 39. It counts out the current time. Pin 10 gets hour pulses. Pin 9 gets minute pulses. Pin 8 gets second pulses. The format HS, MM, SS is fulfilled. Seconds from 40 to 59. It switches automatically to display date. Pin 10 gets the year pulses. Pin 9 gets month pulses. Pin 10 gets day pulses. Interfacing with DS3231 RTC. Read RTC and save all to RTC. The DC3231 communicates using standard I2C protocol via the wire.h library and the address hex 68. It stores time variable as a binary coded. The function BCD to decimal and decimal to BCD acts as a conversion maps layer. They convert the raw register data into standard integer variable so that the Arduino loop can manipulate the numbers easily. Menu navigation using the momentary press switch. Run mode is 0, set mode is 1. Set mode again pressed will give to mode 2. Set mode again pressed will give set day, and the next press of set will set month, next press the year. This cycle repeats, and the set or run final press will load the value entered into the RTC memory. Setting menu continuation. Button routing. Pressing button up or button down adds or subtracts the value depending entirely on the active mode state. Modulo maths keeps the value from exceeding the real world time constraints. Flashing and isolation visual. While adjusting setting, the code stops updating all the screen. Instead, it resets the layout and pulses only the specific register pin you are altering. If you are modifying minutes, only the middle display module will actively clear and pulse up to your set target. Data commitment. Pressing button run at any time or pressing button set when navigating past the year mode, execute save all to RTC. This packs your custom edit to the BCD format and upload them over I2C bus into the DS3231 non-volatile memory bank. 4. Simple audio alarm track. During active running mode, if alarm embedded is flipped to true, the algorithm monitors the current timeline. If the current hour matches with the alarm hours, minutes matches with the alarm minutes, it flags an active alarm event for the first 15 seconds of that minute. This activates the buzzer, follows a clean rhythmic pulse. The buzzer rings during even seconds, silent on the odd seconds. A working image of the clock is captured. Here the clock is running. It will run for 0 to 40 seconds. The photo of the calendar running is captured. From 40 to 60 seconds, the calendar will be displayed. Conclusion. This is an attempt to use decade counter with MCU to show data and date and time. This is cost effective. Most features like temperature, humidity, display can be added. The C++ code is an excellent learning platform for the student. One can contact the author for tips, support, assistance and guidance. Please contact for code and support. Kits are available for learning. Projects for schools and colleges can be designed. Contact the YouTube owner. Subscribe to my YouTube channel. Please subscribe to my YouTube channel by following the link. Thanks for watching. See you in the next episode.